Okay. Fine. So let me ask few questions again, just to have. You're just getting into checkpoint now, okay?
Okay.
From your perspective, if I ask you to define security, how do you define security?
To prevent unauthorized access to the confidential documentation.
Okay, so you're trying to say that then you have some protected resource that can be accessible only for the authorized people. That's what you're trying to say.
Right. Right.
Okay. Is that the only definition for security? Can we have something else?
What else would be like?
Okay. Generally, security means filtering out unwanted traffic. Okay. So most of the time, you used to say that it could be like the traffic could be from a genuine user, the traffic could be from a malicious user. Traffic itself could be genuine or malicious. It could be an attack packet. It could be an authorized user. It couldn't be. It could be from an unauthorized user. It could be anything. From an infrastructure perspective, if the traffic is not required, if you feel that that traffic is not supposed to enter your infrastructure,
okay,
it should be filtered out. That's all. Most of the time, when you do some documentation, instead of unwanted, you could see that as malicious traffic. But actually speaking, instead of saying that filtering out malicious traffic, I would say, if you say filtering out the unwanted traffic, that would be the right definition for security. Say for example, your company doesn't require HTTP traffic from internet. Does it mean that HTTP is malicious?
No.
Okay, so you are going to filter it out.
There is something you don't want.
Exactly, that is what the meaning of security. Okay, now why do we have to do this one? Assume that HTTP traffic is not required. Why do I have to filter out? Because our focus wouldn't be on HTTP traffic at all.
Sorry, what was that?
Okay, if you feel that HTTP traffic is not required to be allowed, why it has to be filtered out? Your company or your infrastructure doesn't have a web service at all. Then why you have to filter out the HTTP traffic? What is the problem? Because you don't have a web server at all. Even if HTTP traffic is coming in, anyway there are no service or there are no server which could respond. Then why it has to be filtered out?
Because it's not trusted?
I'm not very sure. It could be trusted, it couldn't be untrusted also. Right? So if some traffic is not being expected, it is better to filter out because our focus wouldn't be on that specific service.
Right.
If an application is going to be allowed by any of your infrastructure device, it will simply look into it. Okay, is this meant for this specific application or not? If it isn't, it will simply allow the traffic to pass through. What an attacker could do, they could force that the traffic is meant for HTTP, but once it reaches the destination, it could be meant for some other application as well. They could do that now. So it is always better to not allow if the traffic is not expected at all.
Okay.
Okay. Now, why this has to be done? Because we are feared of attacks, or we are feared of threats. Right? We are expecting some attacks from internal people, or it could also be from external people. So what is the purpose of an attack? Mostly either they may try to steal your information, or they may try to destroy your services. This is the maximum they could do it. the information what you have in your infrastructure could be important for an attacker so that he will try to steal it. In a worst case scenario, he may also try to destroy the information which is available in your infra, so that a legitimate user, when he is trying to access, he wouldn't be able to access it. Okay? The threats can be let me say unstructured, structured, internal, external. Unstructured are nothing but a no-wise attacker, a no-wise user who has been motivated because of some people who came across some of the tools available on the internet or known via one of his friends. He will try to launch an attack. Mostly, we call these people as script kiddies. So they don't know where the actual data is residing. They don't know what is the operating system is running on. They don't know where what kind of a network the infrastructure have. They don't know what kind of a firewall or security infrastructure they have placed. Just because of the motivation and just because they know few of the tools, they are trying to launch an attack. It's an unprofessional way of launching an attack. Whereas structured attacks or structured threats, we used to call it is coming from a professional hacker. Right? They know what they want, they know where it is, they know how to get in, they also know how to steal that information. Finally, they will also be covering their tracks. So we normally call these people as black hat. Often we also call some of them as white hat. So depending on the intention of an attacker, we name them as black hat or white hat. Black hat, 100% malicious, white hat, 100% genuine. Why a genuine attacker has to launch an attack against your infra? This is where your PT people will come into picture. Penetration testers. They will
like
try
checking
to
out the weak points.
I'm sorry?
Mean like checking out the weak points?
Exactly, exactly. So that is the purpose of your white hat. Okay?
Yeah.
So internal threats, don't simply think internal threats could originate internally in an infra. Internal threats could be initiated by an authorized user of a network. He could be sitting internal to the network or he could also sit external to the network. It doesn't matter. Internal threats means the threat could be initiated, an attack could be initiated by an authorized user who have access to the network. Again, internal threat could also be structured or unstructured. A disgruntled employee who has been fired, still his account has not been logged. He may try to launch an attack. Right? So external threats, attacks being initiated from a user who doesn't have any sort of access to the infrastructure. An unauthorized user, if he is trying to launch an attack, we call it as what? External threat. External threat could also be unstructured or structured. We have various categories of attacks. Okay, we normally categorize them as reconnaissance, access, DOS. These are all the types of attacks we use to categorize. Name any attack that could fall in any one of these categories. Right? We have various types of attacks on there. So we have to start protecting our infrastructure. Most of the time, whenever we are talking about an attack, people used to say that we have our infra, let me say that this is our network, we are connected to internet, so we are expecting okay. So we are trying to protect our infrastructure. We are trying to protect our infrastructure from internet because we presume that the attacks could come from internet.
Okay.
Correct? But is that true? Is that true?
It can be launched within the environment. I mean,
it could.
by
It could.
internal.
Yes. It could. It could. When you are trying to do some sort of security implementation, we always focus on the inbound traffic. Inbound in the sense from internet, if any traffic is coming, then we have to do the security analysis or screening. But the same level of protection, is that being given for the external network, external traffic as well, or outbound traffic as well?
No.
Okay. Why is this? If you could understand the things better, you can suggest your company. Let's assume that this is where I'm keeping a firewall. Okay. So this connects to my internal network. One interface connects to the public network. So we normally focus on filtering the traffic which is being received from external network. Why is that so? Most of the time, we assume that the attack could be originated on internet. But think that let me create. You have a switch. Let's assume that you have a switch, and you also have the PCs connected to it. Or let's say like this. What is the purpose of a switch? It provides connectivity to the end systems, correct?
Right.
Okay. So in this case, assume that system A has been attacked. From where the attack could come from? It could come from this PC, or it could come from here, or it could come from here. Am I right?
Right.
But we are blaming the switch. What I'm trying to say, assume this each and every PC as a network. Let me call this as network A, network B, network C. Similarly, I also have something called network D. Now this switch is going to be considered as internet. Okay? We are all connected through internet. We are doing the inbound filtering because we are expecting attacks from internet. But actually speaking, no one is directly sitting on internet. Internet is a connectivity medium.
Right.
So every company is trying to do the inbound filtering. But they are not doing the same level of screening for the outbound traffic. Because of that, one of the network could be an attacker for the other network. So the attack could be initiated from one network which is targeting the other network. If every network or every company has focused on outbound filtering as well, or they are focusing on outbound filtering 100%, then they may not be getting any attack through internet. If an attack is being initiated from a network, it will make use of the internet, and then the attack could be targeted on one of the network, correct?
Right.
If the traffic going out of their network can be screened perfectly, then internet will be the safest place to play around. Okay?
Yep.
So anyway, just keep this in your mind. So whenever you are providing a solution to your customer, make sure that the outbound traffic is also being given the same level of importance of filtering. Right?
Right.
Now, let's assume that. Let's take a case. I have a firewall which is connected to internet and which is also connected to LAN. Okay. So we normally call a firewall as a first line of defense. The initial level of screening is going to be taken care by the firewall. Right? So whether the traffic is coming from external to internal or internal to external, which has to be screened through the firewall. But what is the level of screening and how the screening is going to be happening on the device? Based on that, we categorize the type of firewall as either a packet filter or a stateful inspection firewall or a proxy firewall. Okay, a packet filter, stateful inspection firewall or a proxy firewall.
Right.
So you must be knowing about these things. Let's assume that we have a packet filter is implemented here. We have a packet filtering. Now how the filtering will be happening? Okay. So based on your OSA layer, in which layer a data unit is called as a packet?
Layer 3.
Okay. So we are trying to say based on the layer 3 information, because it simply says the packet filter, right? Based on the layer 3 header information, the filtering is going to be performed. So what information could be seen on layer 3 header?
IP.
Exactly, the source and destination IPs is what you could see.
Right.
So you can start writing the rules if the traffic is coming from this IP, going to this IP, whether it has to be permitted or not. That's the maximum you could do with it. Let's assume that I have a server. Where I have my web server is hosted. Let's say this is genesis.com. That's where my site has been hosted. Okay.
Okay.
So what you can do is, while you are writing a policy, you would like to allow the traffic to this particular web server. You have to note down the IP address of it. Let's say 11.11.11.11. So you will be writing a policy which is coming from your LAN network to 11.11.11.11. The traffic needs to be allowed. That's the maximum you can write in a rule. But assume that the same server, I'm also hosting an FTP server. The same hardware, the same physical server, I have a web server installed. I also have an FTP server installed on it. Because of a rule what I have written, I was assuming that the user may access the genesis.com website which is installed on 11.11.11.11. But unfortunately, the service which is available on the same server could also be accessible to the users.
Correct.
You can't protect these things. Okay. So that is where we came up with enhanced packet filter which could recognize the application as well. Instead of simply identifying the traffic based on the source and destination IP, we started identifying the traffic based on the source IP, source port, destination IP and destination port.
Right.
So because of that, if I have to allow the traffic only for the HTTP server, it is possible to write it through a rule. So packet filter is good. But what is the negative side of your packet filter? It is stateless in nature. What I'm trying to say it as a stateless in nature. Let's assume that in packet filter, because it is stateless, you have to write the rule on both the directions. Only then the communication could be possible.
Okay.
Let's say I have my internal device which is trying to access let's say 12.12.12. whatever it might be. Okay. Now I'm writing a rule stating what 12.12.12.12 is my internal IP or the source IP. The source port could be anything because the client always picks up a port number which could be greater than 1023. That's what our assumption. So I'm saying that it is going to be any port number because the client can pick up a port number and random.
Right.
So I would like to say it could be any port number going to destination of what 11.11.11.11 port 80. I would like to allow the traffic. Correct?
Right.
So this will allow the traffic from 12.12.12.12 to 11.11.11.11. But what will happen for the return traffic? So I also need to permit it.
Right.
So what I'm trying to do, I'm also saying that 11.11.11.11, if the source port number is 80, going to 12.12.12.12 to the destination port number of any, I need to allow it. Only then the bidirectional communication would be possible.
Right.
Okay. So
Right.
we know that the communication, how it will be happening. So this guy will be sending a SYN packet. The first packet will be SYN, and followed by what? SYN-ACK,
Yeah.
and then ACK.
Right.
This is how the three-way handshake process is going to happen. Right? These informations are going to be available on the TCP header,
Right.
and these details are not understandable for a packet filter. If a SYN is going out, the firewall shouldn't understand, it couldn't understand the return packet supposed to be a SYN-ACK packet. What would be the negative side of it? Okay, let's say that here also some server is running. Let's say same web server is running. Okay, you have written a rule from 11.11.11.11 from port number 80. If it is going to 12.12.12.12 to any of the port number, it has to be allowed. I don't want this web server being accessible from the external world. But what if someone is sending a packet or someone is sending a request, it is claiming that the packet is coming from 12.12.12.12 on port number 80, going to 11.11.11. It is coming from 11.11.11.11 or from port number 80, going to 12.12.12.12 to port number 80. Of course, this is going to be a SYN packet. What will happen? Will it be allowed or not?
It will be allowed.
As per our rule, the condition is matching. If the traffic is coming from 11.11.11.11 to 12.12.12.12, it should be allowed because the source port number is 80, the destination port number is also 80. The source port number is supposed to be 80 as per the rule. The destination port could be anything.
Right.
So because the SYN packet has been allowed, the web server could send back a SYN-ACK packet. If the intention of an attacker, but the SYN-ACK will be sent to whom? 11.11.11.11, who will be wondering why you are sending a SYN-ACK packet, because I have never given a SYN packet to you at all. Correct?
Right.
But anyway, from my internal service perspective, the state of a connection would be in a half open, because I have received a SYN, I have sent back a SYN-ACK packet, but I am waiting for an ACK packet to establish a connection. But actually speaking, the packet is coming from an attacker who has spoofed the packet with the source IP of the genuine source. So he wouldn't be receiving the SYN-ACK packet, so obviously he will not be sending an ACK packet also. So the attacker will keep on sending a SYN packet to cause a SYN flood attack, so that the web server couldn't be accessible by the genuine users. So what I'm trying to mean it as, the firewall doesn't understand the state of a connection, even though a packet is going internal to external with a SYN flag set. If the return packet is not a SYN-ACK packet, the firewall couldn't understand it's a response or not.
Right.
Because of that, it will check the rule every time, and if the rule says the traffic could be permitted, it will be permitted.
Right.
So if hundreds and thousands of packets are going to be transmitted from the same source to the same destination for the same service, I mean to say that it's part of the same session, every packet needs to be matched against the rule base. Right? Which is,
Right.
the packet filtering technology is good, but to a certain extent. What we are expecting is sort of sophisticated or a granular filtering technology. Your packet filter is faster, but it is not granular. That is where we came up with something called as what? A proxy firewall. Who's that?
Phone.
Oh, okay. Okay. What a proxy will do? I hear that someone just waking up.
No.
Okay. Now let's assume that I have a firewall now. I have a filter now. Same internal network and external network. So I have a server located here with the same IP address. Which is a web server. The response is good than Skype or what?
Skype was better, I would say, in terms of response.
Skype is better, huh?
I just saw like there was a delay. Like I think that last diagram that you started, like I started seeing it like once you draw like the 3 blocks of it. Like I saw it like once you. Yeah.
What do you say? But you would like to go with Skype?
Actually, honestly, like I want recording for the sake of like later on I can watch and make notes out of it.
Okay.
I don't know if Skype has that option.
No, Skype doesn't have that option, but I need to look for something called Camtasia, some screen recorder tool. We have to work with it.
Okay.
Anyway, so you would like to stop this one and start initiating that one?
Which one?
The Skype?
I think I'm good with this one, if you don't mind. Yeah.
Okay, fine then. So I have a web server, same like I have some internal clients. I have my internal network as well. They are connected, and of course my internet is there. So what a proxy will do? Proxy sits between a client and server. Okay?
Yep.
Now, whenever a request is coming from my internal clients or whomever it might be, and a request is being initiated by the client, like who is Genesis.com, or who is Google.com, and who is Yahoo.com, who is Microsoft.com. For all of the client requests, he will raise his hand. Okay, I'm Yahoo, I'm Google, I'm Genesis, what do you want? So from client perspective, who is Google? My firewall or my filter. So all of the requests initiated from the client will be targeting the proxy, including your destination IP address. So because from client's perspective, the server is proxy. You ask for any server detail, you tell me that who is Genesis.com, proxy will raise his hand and it will say that I'm Genesis, what do you want? So client sees proxy as Genesis.com web server. So he will be constructing the request directly to the proxy, not to Genesis. You understand? So because of that, the request is going to be received by the proxy firewall, can see all the headers matching because the destination MAC address will be matching, the destination IP address will be matching. If these two are matching, then obviously I'll be able to open up the layer 2 and layer 3 header and start proceeding further. So all the headers are going to be opened up. Because of that, the proxy could also see the payload.
Okay.
Because the proxy firewall has visibility on all the headers and payload, it can be configured to do filtering based on any of the header value of all the application, all the OS, all the layers, as well as the payload. So the proxy has visibility on all the headers as well as the payload. So the filtering could be possible based on any of this information.
Okay.
So the request has been initiated by the client to the proxy because client assumes that the proxy is the server.
Okay.
So the proxy has opened up all the headers and the payload is visible for him. Then he will forward that as his request initiated from the proxy targeted to the original server.
So how does like client assume that the proxy is the web server?
Because whenever it is generating a request, the proxy will say I'm Genesis.
Okay.
So first of all, the name query has to be going that. So initial question will be what? What is the IP address of Genesis.com?
Okay, so it has a cache that has the
It is
IP
not
for.
cache. It is not cache. It is not cache. The proxy would have been configured in such a way that for any of your questions, they used to start writing the script files. Probably you would have seen something called the proxy.proc script. You would have associated to the browser. That script will be having all those information.
Okay.
Okay, I'll tell you one thing. Now assume that, okay, this is me. This is Gopi. Okay?
Okay.
And let's assume this is Zubair. This is Zubair. Okay? Now, the language what I know is Tamil. Do you know Tamil?
No.
Okay. Okay. Now, you tell me your mother tongue. What is your language?
Urdu.
Urdu, which I don't understand. Okay? Now, we both of us have to talk to each other. How it is possible?
Right. We need a translator.
I need a translator. Okay? Now, the translator is supposed to know both the languages.
Right.
Correct? So, whenever I'm trying to pass the information, I have to send it to the translator. So, the information actually meant for Zubair, but I'm sending it to the translator. What the translator has to do, he has to understand the meaning of communication, and then he will translate the same in Urdu and it will be given to Zubair.
Correct.
From Zubair's perspective, from where the packet is coming, it is coming from the translator.
Right.
So to whom he has to reply back? Assume that I'm asking a question. The question will be translated by the translator and will be sent to Zubair. The Zubair is receiving the question from translator. So he has to reply back to the translator only.
Correct.
Now the translator knows the details of this communication. So this traffic is meant for Gopi. He will translate the same in Tamil and give it back to me.
Right.
Do you understand?
Yeah.
Okay. So this is what a proxy is also doing. So proxy sits between a client and server. Proxy has two phases. One is the server phase, the other one is the client phase. Server phase will be shown to the clients and client phase will be shown to the servers.
Right.
So all the traffic coming from the client will be decapsulated at the proxy and then encapsulated from the proxy to the target. Similarly, any responses coming from the server will be decapsulated and re-encapsulated and sent to the client. So it is more granular.
Right.
Because of this additional decapsulation and encapsulation, the latency could increase. Right? So we have a packet filter which is faster but not granular. So we came up with a different technique which is called as a proxy firewall, which is more granular but it is not faster. So we need a balanced filtering technique. That is where the stateful instruction firewall came into picture. Now, what a stateful instruction firewall is going to be doing it? Let's say the same set of setup. I have my external server. I have my internal network. So this is on 11.11.11.11 on web server. Okay. Now these are all my clients. I have a firewall which is of type stateful packet inspection. Stateful packet inspection is also can be compared with Cisco's technology of reflexive access list. You might have worked on it, right? So what
I have not.
Oh, okay. Then let me explain you what is that going to be happening. So in stateful inspection firewall, it is also a packet filter which has the ability of understanding and maintaining a state of a connection.
Okay.
Assume that if the traffic is going from client to the server, client to server, you have to have a rule to permit it. You have to have a rule to permit it. But the return traffic, you don't need to have a rule. What I'm trying to say, assume that I have a table. This I call it as a state table or connection table, whatever it might be. Now the traffic is coming from 10.10.10.10. The source port number is 1050. It is going to 11.11.11.11 on port number 80. Right?
Right.
And it also going to record the flag as SYN because it's the TCP packet. And it also going to maintain, it will also be recording the other details like the timeout and sequence numbers and all. When the traffic is being identified, it also mentions the direction. The traffic is coming from internal network to the external network. It makes another entry because of this entry. It creates that 11.11.11.11.11 from port number 80. If it is coming to 10.10.10.10 to the port number 1050, allow the traffic. So if at all this has to happen, which one? This rule needs to be taking effect. The initial connection needs to be established first. If a SYN packet is going out, the SYN ACK needs to be received. ACK needs to be sent by the client. Once the connection has been established, these rules are going to be in effect. And this is being derived from the policy what you have configured in, what is that called, in a firewall. Whereas this is the effect of the request which has been permitted to pass through. You understand what I'm saying? So the return traffic, you don't need to have a rule. If the request is being permitted, the reply or the response will also be permitted to pass through.
So you have a mapping in the table, right?
Exactly. And this table often called as a connection table.
Okay.
Or we also call this as a state table. Right?
Right.
The state, sorry, there is a spelling mistake, I'm sorry.
Right. So
this is also called as.
we all are used to the autocorrect option in iPhone.
Okay. So the state table is going to be there, which will maintain the state of a connection. And when a connection is being cleared, that entry is also going to be taken out from your state table. Right? So, a stateful packet inspection is a firewall which is faster than proxy and granular than packet filter. So stateful packet inspection or stateful inspection firewall is a technology which has been developed and patented by Checkpoint.
Okay.
So our focus is going to be on Checkpoint firewall and how it works.
Okay. So I have a question, like might be a little dumb one, like listening to what you just explained. Then why do we have proxy and a firewall together at a enterprise?
Okay. I'll tell you one more thing here. Let's understand. I have a perimeter router. So that's a typical design, right?
Yeah.
I have a perimeter router which is connected to internet. I have a firewall behind it. I also used to have a switch between a firewall and the router. Why it is so? Because I would like to connect an IDS device here. Okay, behind I may also have an IPS. It's a typical scenario, right? Okay, now my question is, if you have a firewall, then why do we need an IPS?
I don't know.
Okay, now normally the traffic, the IPS has the ability of screening deeper inside a packet. It can dig deeper. It can look into additional information, or as per the rule what you have configured on IPS, it can identify some sort of attack in a great level than your firewall.
Okay.
Now then why we have a firewall then? That would be the question. I can keep IPS, right?
Yeah.
The point is, if you are going to have an IPS alone without a firewall, all traffic has to pass through the IPS, which will cause a lot of delay. Right? So in firewall, so that's what we were talking about, the first line of defense. It will do a basic level of filtering, which we call it as a stateful inspection firewall, better than any other filtering technology. Whatever the traffic is being permitted to pass through the firewall, I would like to undergo additional screening.
Okay.
So because of that, the firewall is going to drop any unwanted traffic to be permitted. Those traffic is not at all going to be screened by the IPS at all. So whatever the traffic is being permitted by the firewall is undergoing the additional screening.
Okay.
So this is what a good example of what you have asked. So normally we use proxy for outbound.
Right.
Right, when the traffic is being permitted to pass through from your internal network to the external network, it will undergo some additional screening by the proxy, because the additional modifications on the traffic could be possible.
Correct.
Whereas the inbound traffic, we are not going to be sending to the proxy.
Okay.
Right? Even though the proxy is permitting the traffic, you may be having some global rules on the proxy that HTTP traffic needs to be allowed, and this is how it has to be modified. If some of the users are not allowed to access the HTTP service, then where do you write it? Instead of writing in the proxy itself, you can write it on the firewall, because you may have some HTTP services internally is available.
Right.
If I'm going to block the HTTP traffic on the proxy, and the users couldn't access the internal HTTP servers also.
Okay.
If the traffic needs to be permitted to access the HTTP server which is available internally, then don't write the policy on the proxy server. The proxy is going to
firewall.
Exactly. When the traffic is going out of the firewall, it could be blocked. If it is coming from that specific IP, it could be blocked. Right?
Yep.
Okay. I think more of theory today, right?
Yeah.
Okay. Slowly I'm just directing you towards the checkpoint.
Yeah. Thank God, no questions.
I used to say only in 2 situations there won't be any questions in the class.
When is that?
Situation number 1, if you don't understand anything, there won't be any questions.
Okay.
Situation 2, if you understand everything also, there won't be any questions.
Okay.
But it wouldn't be possible in any class.
Yeah.
So you may get something and then you have to start asking the question so that your doubts could be clarified. But anyway, today a lot of technological explanation, so probably there won't be any question. When you go through again, you may be getting some answers for that. You may be getting some questions.
Yeah.
Okay. Now let's come back to what? A checkpoint. Checkpoint is a firewall package, right?
Right.
Developed and patented by, of course, the stateful inspection firewall, developed and patented by Checkpoint. They came up with a firewall. Let's assume a firewall as an application. Okay? Comparing to MS Office. Like, okay? Now, if at all MS Office has to be installed on a hardware, what is a minimum requirement? You need to have an operating system on it.
Right.
The operating system could be anything. Of course, most probably we will be working with Microsoft Windows. Similarly, if firewall has to be installed, then you have to have an operating system.
Right.
If you want MS Office, then you need an operating system. Without that, it is not possible. Similarly, I'm comparing firewall as an application. If firewall has to be there, since it is an application, it can be hosted on top of an operating system. So that is mandatory here also.
Right.
Okay. Initially, Checkpoint has come up with something like what? Hardware can be anything. OS can be anything, but it should be network-based operating system. So if you have some open servers in your infra, make use of it. If you have any Linux server or Windows server or Solaris server, you have anything, I don't have any problem. So take any hardware, take any operating system, install on it. On top of that, the Checkpoint firewall could be installed. So this is where initially Checkpoint has started with. So Checkpoint has given the liberty to the customers that they can use any hardware. They don't need to buy the hardware directly from Checkpoint because they were not having it. Similarly, you can use any of the operating system, whatever you are comfortable with. If you are comfortable with Windows, you can use it. Windows NT 2000, whatever you want, you can use it. Similarly, Linux or Solaris, whatever you want, you can use it. So make sure that the system is operational. Means after you install what is it called, an operating system on a hardware, then you can buy Checkpoint alone from Checkpoint. Then you can install on it. Then it will be acting as a firewall. Do you understand what I'm saying?
Yeah.
Okay. So you choose an hardware, install an operating system, and then the firewall from Checkpoint. This is how it will work. Okay. So because of this, if you're choosing a wrong hardware, a wrong operating system, sorry, you cannot expect the performance. Okay. Let's assume that Windows 10 is being installed on top of a P1 machine with the 1 GB of RAM. How it will be?
Right.
Is it a problem with Windows 10? No.
No, the hardware.
Exactly. Similarly, you have a firewall called as a Checkpoint is installed on top of an operating system which we don't have any control on it, and that operating system has installed on a specific hardware where we don't have any control on it. If the hardware is not capable of handling a volume of traffic, then the Checkpoint performance wouldn't be as expected.
Right.
There is also saying that if a OS could be compromised, then the applications whatever installed on that could also be compromised.
Right.
So people were worried about these things. Okay, I don't know which hardware I have to use. I don't know what operating system I have to use so that it will be more secure. The Checkpoint firewall package is too good. You understand what I'm saying?
Sorry, yes.
Okay, so what the other OEMs started doing it, like Nokia, Crossbeam, of course Nortel. What they were doing is they have developed a hardware, specialized, and an operating system hardened. Okay. So they develop the hardware, specialized hardware, and they've also developed an operating system which is hardened operating system. And then they made a tie-up with Checkpoint. That means they used to buy the firewall package alone from Checkpoint, and they used to sell it as Nokia firewall, cross-beam firewall, Nortel firewall. You understand what I'm saying?
Yeah.
Okay, so Nokia Checkpoint firewall, cross-beam Checkpoint firewall, Nortel Checkpoint firewall. This is how they were selling it. They had a good demand. People were buying this product because of Checkpoint, but not directly from Checkpoint. Okay, now these people started getting some good business. Okay, that is well and good. I'm not at all denying that one. But anyway, Checkpoint is also being sold. Why customers are running behind these OEMs? Because they developed the hardware which is giving good performance. They developed an operating system which is hardened, and they were also having a tie-up with Checkpoint, and they are installing the Checkpoint on top of this hardware, and they are selling it as a solution firewall. So you don't need to worry about, as a customer, I don't need to worry about what hardware I have to use, what operating system I have to use. So Checkpoint started thinking about it. So initially, after this kind of an analysis, Checkpoint came up with an operating system which is called as Checkpoint Secure Platform, often known as PLAT, which is based out of Linux.
Okay.
Right? Secure platform, Linux based. So still the hardware could be anything. So again, later on they acquired Nokia. Who? Checkpoint acquired Nokia. So they also know the hardware manufacturing technique or hardware development. They also got an idea how an hardware is being manufactured. So after the acquisition of Nokia, so they got a hardware plus an operating system plus a firewall. Checkpoint is selling firewall as a product, but they felt that Linux is an operating system which is running on, developed by Checkpoint. But anyway, when Nokia was working with it, they developed something called as an IPSO as an operating system,
Right.
which is based out of FreeBSD, Unix. So when after the acquisition of Nokia, they were working with the hardware. Of course, they got the hardware technique, and when they were thinking of operating system, they merged the benefit of SPLAT and IPSO together. They came up with an operating system called as what? Gaia. That's the current operating system which is available. Okay. Now Checkpoint has a product, a hardware, an operating system, as well as a firewall. So they are having all in the hardware and they're selling it as a product. Now the customers no need to search for any other OEMs or the vendors. They are directly buying the hardware from Checkpoint. As like any other OEMs, Checkpoint has a lot of models, the products. You have enterprise class, you have service provider class, a variety of products are available. So depending on your requirement, you may choose the right products which can fit into your infra. Even a small company, a UTM box could be purchased. If your company is big, then according to your requirement, you have a variety of boxes, 4000 series. So if you go to the Checkpoint, you will be able to see them. See? Home of consumer, you could see the firewalls. Working. Sorry.
Hello?
Hello. Am I audible?
Yeah.
Okay. I think. I'm not able to share screen.
I can see your screen.
I'm able to see my screen. How come it is possible? Because
I don't know. I see an error. WebEx application has encountered a problem and needs to close.
that is where it got stopped, right?
Yeah. Want to disconnect the
I guess I think so.
Screen sharing?
Now
Okay.
you are now the presenter. Now it's okay. Now I got back.
Okay.
Now I'm able to share my screen. Now it's going on. Recording is going on. No problem at all.
Okay.
So where we are? Okay. Now checkpoint has a hardware. Okay. So that's where I stopped it. I guess. Okay. Okay. Now if you go there, you can go by category wise, or you can also go for the firewall. Okay. There is nothing given here. See, these are all the models you can see this photo. You go for compare all, you will be getting the complete set of items, every model, what is the capacity of it. Starting from the branch office, the model number of 1430, 1450, like that, it will go. Enterprise level is 15,400. You have, depending on the size of your infra and depending on your requirement, you may choose the right model. You may also think of what is the throughput that you are expecting, firewall throughput, what is the number of concurrent sessions, connections per second. You just need to work on all these things. Based on that, you may be choosing an appliance. It's not being shown. If you see the image, it looks like to see this is how the boxes will look like. So you can use these interfaces to get connected to your internal and external. Like a typical router, you can use these things. So okay, now we have everything. Okay, now how we are going to perform, or how you just need to understand the architecture of your checkpoint firewall as well.
Okay.
So first of all, now checkpoint follows something called as a blade arc. What is that blade? Okay. Let's say that I have something called as a physical server. I have some resources inside, some RAM, some CPU, some storage area, right?
Yep.
I have installed many applications on it. So any application can use these resources for its operation.
Right.
If one of the applications is going to use all the resources available, the other applications may suffer.
Right.
Mostly, if you see that if you are downloading a movie using something torrent, like something like that, then the whole bandwidth could be allocated for that, and if you are using some general internet accessing, it would be very slow.
Right.
So what I want to do is I would like to reserve the resources for each and every application, so that it can operate in its own protected space.
Okay.
So those resources wouldn't be available for the other. So what I'm trying to do, I'm trying to have multiple hardwares now, right? In this hardware, whatever the resource available, only one application is hosted into it.
Okay.
This hardware, the resources are available for, there is an application which is hosted on it. Again, I have a hardware and its own application has been hosted on it. Assume that these are all the virtual machines and you have a physical hardware as well. Now what will happen? This virtual machine has its own set of resources, an application hosted on it. This application makes use of that specific resources alone. And if something goes wrong with this virtual machine, that will not affect the associated virtual machine.
Okay.
They have their own resources. They will operate. Similarly, what I'm trying to say, Checkpoint came up with a blade architecture. So every feature, let me say, a firewall itself is a blade. Your IPS is a blade. Right? So it will be having its own set of protected resource and it will operate only in that specific area. So if one blade is having problem, the other blade is not at all going to be suffered. Do you understand?
Yeah.
Okay, so this is what we typically call it as a blade architecture. How many blades can be installed on a single hardware is purely dependent on the hardware model.
Okay.
Right, that you have to read the data sheet, how many blades could be enabled on it. Now, the next part again, checkpoint arc. Let's say that, which we used to call it as a 3-tier architecture. What is this? Let's understand. A checkpoint's kernel is known as inspect.
Okay.
which is a low level language. We don't understand it. Okay?
Okay.
The inspect language sits between layer 2 and layer 3. Other way, we used to call it as layer 2.5.
Okay.
Let me explain where it is going to be. Okay. So I have a network layer. I also have my data link layer. This is what my physical layer is. Your inspect engine is going to sit here. Okay.
Okay.
So when a packet is being received on an interface, the first visible layer would be what? The physical layer. If everything is matching, then it will be handed over to the data link layer. The data link layer will match whether the MAC address is matching mine or not. And then after the layer 2 has been processed, it has to be handed over to the layer 3. But between layer 2 and layer 3, I have my checkpoint kernel where the policy evaluation will be done.
Okay.
So if the firewall policy says that it can be permitted to pass through, only then it will be handed over to the TCP/IP stack, where you have your routing table. Based on that routing table, the route lookup can be performed. Right?
Right.
So this is where your inspect kernel sits, inspect engine sits. So you have to write a policy in inspect.
Okay.
The intelligence of your firewall is at layer 2.5. So you need to give the inspection in layer 2.5, which we don't understand. Right? So that is where checkpoints architecture comes into picture. I have a gateway. I call this as a gateway, which understands the language of inspect. I am the administrator who understands only English. Now, how do they talk to each other now?
There's a translator in between.
Obviously, we need a translator. The translator in checkpoint, we call it as a management server. Okay?
Okay.
So management server is going to be connected from your admin PC. So you are going to connect to the management server, and then from management server the instructions could be passed to the inspect engine.
Okay.
Similarly, if anything needs to be shown back to the administrator, it will come to management server, and then which can be visible by the which can be visible for the administrator. You understand?
Yeah.
Okay. Now, this is the component number 1. I call it as, this is component 1, this is component 2, and this is component 3. So because of that, we call it as a 3-tier architecture. Okay. Now the point is, checkpoint calls all their products as what? It's a smart gateway. It's a smart management server. Okay. So management server is an application. To get connected to that application, you need a client which is known as a smart console. So using the smart console, you are connecting to the management server, where you are doing all the changes, and then it has to be pushed to the gateway. So smart console is a client that could be installed on your admin PC or laptop. Right?
Right.
Management server and gateway is going to be available on your appliances. Okay, so that is where another difference comes into picture. I can have this in a hardware one, and this could be in a different hardware. So your firewall blade or the gateway and management could be in a different hardware altogether.
Okay.
If I do that one, then I call it as a distributed installation of checkpoint. if both the services, management server and gateway, is running on the same hardware, then I call it as a standalone installation.
Okay.
Right. So distributed installation and
A standalone.
Standalone installation. Okay. Now whether it is a distributed or standalone, the communication is going to come from whom? An administrator.
Right.
So this is going to be connected through the network. So the communication needs to be secured from console to the management server and management server to, what is it called? The gateway. Right. So typically this will be using your HTTPS. Okay. And this is going to be called as a SIC. Secure internal communication.
Okay.
Right. We will discuss about these two when we are doing the installation and what is the significance of it.
Okay.
Okay. I guess today I have created a lot of theory today also. Okay. Are you able to understand?
Yeah.
Good. Okay. I'm just going to stop here. I'll be allowing you to do some sort of review.
Yeah, for sure.
Then we can start doing the installation.
Yep.
Okay.
Yep.
Okay. Let me stop the sharing as well as let me stop the recording. I don't know. I'm not able to see this.
You will get an email, I think.
Is it?
Yeah, you will get an email with the recording.
Oh.
You can stop it.
I don't have a recorder. Okay, I have an option of stop.
Yeah, it should be on the top.
Recording.
Yeah.
No, separate recording. Okay.